So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. Okay, so welcome back. Today we are working on lesson number 6 in Unit 2, our proportional relationship unit. So today we're going to be learning about rate of change and slope. Our aim is how do we determine rate of change and slope from a graph and a table. And here's our warm-up. So you're given a graph and you're given a table of information. It's also telling you that how can we calculate the constant of proportionality? And they're telling you that the constant of proportionality is 5 gallons per minute. So in each of these, the graph is saying 5 gallons per minute, and it's 5 gallons per minute here. So let's go back to what we've learned in the past. And if we look at our table, we know in order to find our constant of proportionality, we want to say y divided by x. That's going to give us our unit rate. Our time most usually is going to be our x, and the gallons are y. And if you notice on the graph, it's matched up the same way because gallons are lined up with your y-axis and time is your x-axis. So here we're just going to figure out 10 divided by 2, 15 divided by 3, 20 divided by 4. Doing this will show us that when each of these are divided, you're going to get 5 as your answer, which is basically your constant of proportionality. So that's how you would calculate constant of proportionality in a table. In your graph, a proportional relationship, you need to know passes through the origin, which is 0, 0. It's a straight line. And you also could tell where your unit rate or your constant proportionality is, where 1, your value of y is. So if you look at the graph, your 1, y would be at this point, which if you look, each interval is increasing by 5. So this would be 5. So your coordinate point would be 1, 5. And that's how you get your 5 gallons per minute. So let's move on to the notes. So slope is basically talking about the slant of your straight line on a graph. You're going to see different types of slopes. You're going to see a slope and you're always going to read it from left to right. So you're going to go left to right in reading the coordinate plane and the graph. So when you have a graph going left to right and you're focusing on this piece right here, this is a positive slope because going from left to right is it increasing. If you have a slope like this part, going from left to right, it's going downwards. So this would be a negative slope. So this also means that your value of the slope will be negative for a negative slope, and the value will be positive for your positive slope. If you look at the next portion, it's a horizontal line. Slopes like this are called zero slopes because you're not going up or down, you're just going horizontally. So there's a distance you're going horizontally but not vertically. And when we start looking at the formula, it's going to make more sense how you get that actual number 0. So if you have a slope of 0, that's your value, you would have a horizontal line like that. So the next one would be a slope that's vertical. This vertical line is undefined. An undefined slope, it doesn't travel horizontally, it only travels vertically. So that's how it gets his undefined value. There is no value. Usually you see this when it's divided by 0. So your slope here would be divided by 0 because, again, it's not going horizontally, it's just going vertically. So now that we learned a little bit of what a slope would look like in the different situations, whether it's positive, negative, 0, undefined, let's talk about how to find and calculate your rate of change in slope. And just to go through this, your rate of change, whenever you see that, is synonymous with slope. So they're interchangeable. They mean basically the same thing. You're trying to find a rate, a ratio, comparing a unit with usually time or maybe amount of money for item. So very similar to what we were talking about with unit rate, with constant proportionality. This is how it all ties in. Your M is your slope. The first way that you can do this, and usually it's done using a graph or coordinate plane, you're going to look at your rise. So basically how much it's increasing or decreasing. If it's an increase, it's plus. If it's a decrease, it's negative. And then you have run, which is your horizontal distances, whether it's adding or subtracting. Again, it could be positive or negative. Obviously, you would apply your positive and negative rules with division. Another way you can think of it is your change in y. So what's the change in your y values divided by your change in your x values? Again, it could be a positive change or a negative change in y or x. And then you have the slope formula, which is y2 minus y1 over x2 minus x1. We're trying to find the difference between each point. So here you would need 2 points in order to use this formula. So you would label them x1, y1, x2, y2. And that's where you're going to be placing your coordinate points and how you subtract them. Let's try it in the first example. So in the first example that they're giving you is a graph. So like I said before, you'd want to use your rise over run. So the rise is the increase, positive and negative vertically, and the run is horizontally. Okay, so going from point to point, you're also given 2 coordinate points. So we'll also look at how to calculate it with the slope formula. I am going up 1, 2, 3, 4, 5. So I'm adding 5 plus 5 over. And I'm going horizontally positive 1. So my slope is positive 5 here. And that's using your rise and run method. I want to use my slope formula. So let's take 3 comma negative 1. I have 4 comma 4. And my slope formula is m equals y2 minus y1 over x2 minus x1. So I'll only do it for this one to show you. So I have, let's label these. x1, x2, y1, y2. Now all I have to do is substitute in your values where they should go. So if I know my y2, it's going to go here. My x2 is going to go in the denominator. My y1 is in the numerator and my x1 is in the denominator. So then this would become y2, which is 4, minus, and now y1 is a negative. I always like putting that in parentheses because you got to see that double negative happen, over x2, which is 4, minus 3. So now I just simplify. I know my double negative becomes plus, so 4 plus 1 is 5. 4 minus 3 is 1, and really my slope is still 5. Same thing. So whether you're using your rise over run, whether you're using your slope formula, as long as you're doing the math correctly and adding everything up and simplifying and following your formula, you will find the same answer. Let's go to number 2. So number 2, we want to find the rate of change. So I want to find the change in y over the change in x. Remember, y over x is going to give you the slope, but it's a change. So I need to find the change in y, which is just, you're adding 0 because your y is staying 1. And then your x, you're just adding 1 to each value. So I'm going to put 0 over 1. And now this is what I was talking about with your slope. Your slope is going to equal 0 because 0 divided by 1 is just 0. So you have a 0 slope. Your slope is 0, which would mean it's a horizontal line where y would equal 1. Okay, let's look at number 3. Number 3, you're given 2 points. So I'm going to label my points x1, y1, and x2, and y2. Try this one on your own, pause the video, and come back and check. So here I want to use my m equals y2 minus y1 over x2 minus x1. I'm going to substitute in my values. I'm going to get m equals 1 minus a negative 5 over x2, which is 1, minus negative 2. If I simplify, I'm going to get 1 plus 5, which is going to be 6. And then I'm going to get 1 plus 2, which is 3. So 6 divided by 3 is 2. Your slope here would be 2. For number 4, you have a coordinate point. Try this one on your own, pause the video, and come back and check. Okay, so for this one, I highly suggest using rise over run to find your slope. All right, so going from left to right, as always, I'm going to start with this point here. 1, 2, 3, 4. I'm subtracting 4. And then I'm going to the right, 1, 2, adding 2. So then I get negative 4 divided by 2 is negative 2. So my slope would be a negative slope, and if you notice, it is going from left to right, going down. It's decreasing, so that's how you get your negative slope of 2, negative 2. All right, so make sure you're identifying your keyword, make sure you're asking and writing down questions, and I will see you guys in the next video. Bye.